Welcome back to Geometry Classroom. Today we'll talk about another trigonometric ratio called cosine. Yeah. So it's pronounced cosine. Again, a few things to remind. The sides of a right triangle are given special names, right? So the hypotenuse, the opposite, and the adjacent sides, right? The hypotenuse, as we know, is the longest side in the right triangle and is always opposite the right angle. The opposite and adjacent sides refer to another angle other than the 90, right? So how we identify the opposite and adjacent side? We mark the given angle and we find or try to locate the sides in terms of the given angle. For example, in this case, the marked angle is A. So this side, because it's face to face, right, or across the given angles, is called opposite or is opposite. And the other side, yes, is next to the marked angle or the given angle, and that's why we call adjacent. In this picture, again, the marked angle is A. This side is across angle A or is opposite to angle A, right? And the other side is next to angle A. That's why we call it adjacent. Good. As a notation for angle, in our lesson, we use this letter, is a Greek letter, and is pronounced theta. So, what is the cosine ratio? The cosine ratio is the ratio of adjacent side to hypotenuse. Because hypotenuse is the longest side, this ratio is always less than 1. So, all the time, we can say cosine of an angle, for example, theta, is always less than or equal to 1. Yeah? So, cannot exceed 1. Good. So, how we identify adjacent? We mark the given angle, and this side, right, is adjacent because it's next to angle theta. And this side is hypotenuse, is the longest side, is opposite to the right angle. Now, let's have a few types of problems involving cosine. In fact, we have two types of problems with cosine ratio. First type is finding the cosine ratio when the sides of the right triangle are given. And type 2, finding the missing side when the cosine ratio is given, right? Now, when we have type 1 problem, in other words, when the sides of the triangle are given and we need to find the cosine ratio, we have to follow these steps. So, if no diagram is given, draw one yourself. Then, mark the right angle in the diagram. Why? Because if we mark the right angle, we should be able to identify hypotenuse easier. Then, step 3, show and mark the length of any lines that are shown. Yeah? Step 4, mark the angle you have to calculate. Why is it important to mark the angle? In order to identify the adjacent side that is involved in computing cosine ratio. And then step 5, use the formula for cosine ratio. Simple. Then check that your answer is reasonable. In other words, we know the cosine ratio is less than 1. If for some reason we get a number larger than 1, is something wrong. We have to recompute the cosine ratio. Good. Let's have a practice problem. In this example, we need to find the cosine of angle C, right? So, because it's angle C, we have to mark the angle C, right? That's the angle. Now, we know cosine of angle C would be adjacent side over hypotenuse. Yeah? So, we mark this angle, and first we identify the adjacent side. The adjacent side for angle C is this side. Why? Because this side is next to angle C. Yeah? So, the ratio would be 6 is on top over hypotenuse. Hypotenuse is given by the length of this side. Why? Because this side is face to face to the right angle, right? So, is over 14. As any fraction, right, we can simplify. In this case, we can simplify or bring to the simplest form. Now, 6 and 14 are both even numbers, so they are divisible by 2 both. So, if you divide by 2, 6, you get 3. If you divide by 2, 14, you get 7. So, the resulting ratio would be 3 over 7. That's the cosine ratio in this case. Now, in the second case, we also need cosine of C. Remember, we have some steps. We draw a diagram, so it's already there. Then, next step, we mark the given the angle we need to compute, yeah, and this angle is angle C. So we mark. Good. Then the other sides are already there; they are marked. Next, we use the formula for cosine ratio to find the cosine of angle C. We know cosine of angle C is adjacent side over hypotenuse. Now, we have to identify the adjacent side. We know adjacent side is next to the angle C. And the side next to the angle C, right, is 12. 12 is the adjacent. So, 12 goes on top of the fraction. And hypotenuse is the side opposite to the right angle, right? Face to face or across the right angle, yeah? So, hypotenuse would be 15. So, 15 goes in the bottom. And then we simplify the fraction. In this case, we can also simplify. So, both 12 and 15 have 3 as a common factor. So, if we divide 12 by 3, you get 4. If you divide 15 by 3, we get 5. Yeah? So, the final cosine ratio would be 4 over 5. Good. That is type 1. Now let's have one example of type 2 examples involving cosine ratio. So when you have type 2, again, we draw a diagram if there is no one. Step 2, mark the right angle in the diagram. Show and mark the length of any line that are known. Then step 4, mark the missing side that you have to calculate. Use the formula for cosine ratio and solve it for unknown. And check that your answer is reasonable. Good. So, consider this example. This time we need to find the length of the missing side. So, the diagram is drawn. The right angle is marked. The angle that we are looking for is also marked, yeah, is 30 degrees. It says find the missing side. The missing side is denoted with K, lowercase. Now, we use the cosine ratio, right, to find the missing side. Yeah, cosine of angle 30 would be equal, remember, adjacent side over hypotenuse. Now, the adjacent side in this case is K. Why? Because K is next to angle 30. So K goes on top over hypotenuse. Hypotenuse is the longest side. We know is across right angle. So hypotenuse would be 7. So let's rewrite this equation, this ratio, again, as a proportion, right? So we have cosine of 30 degrees over 1 equals K over 7. Now, as we know, a proportion is solved by using cross product. We cross we use a cross product, yes. We multiply K by 1 and cosine of 30 degrees by 7. So you're going to have 1 times K equals 7, right, times cosine of 30 degrees. But 1 times K is K, right? K would be 7 times cosine of 30 degrees. Now, let's evaluate this product. Yeah. So we go here. Yeah. So we multiply 7, right? We press 7 times. Then to access cosine, we press button trig, and we select cosine, and inside the parentheses, we simply type 30. Then we simply press enter. We hit enter. So we get 6.06, right? So K would be 6.06, or about, let's say, K, if we round to the nearest tenth, we have 6.1. So that's all we have for today. We'll have another lesson with tangent ratio, but in a near future. So thank you for watching my video.